Hi, I'm Jim from Hammond Valve, and I'd like to take the next few minutes to introduce you to the IR9253 wafer check and the IR9254 globe check valve, and the subtle things you need to know to properly install your check valves. Let me show you the difference between the two body styles. Both operate in exactly the same way, but as you can see, the wafer style is considerably less material and therefore less expensive, but it has a slightly higher pressure drop. The globe style has this nice bulbous shape, making it much easier for the water to pass through. Let me mention what makes the non-slam, center-guided, spring-loaded check valve different from other check valves. From full open to full close is a very short stroke, and it closes very fast. Let's assume the pump is in the basement of the building, and you're pumping water up 10 or 20 stories. As the pump shuts down, and just before this 20-story column of water had the chance to start to reverse and go backwards, this valve has closed. With the valve closed, no slamming, no water hammer, no destructive or annoying banging. These valves are typically used on the discharge side of the pump, and it's especially important for multiple pumps with a common header or manifold. When only one pump is running, we don't want water running backwards through the others. I should also mention that we would like to see the valve installed 4 to 5 pipe diameters away from the pump discharge. Flow coming right out of a pump is very turbulent, and it will cause uneven seat wear. On the inlet side of the check valve, we recommend a full face gasket, and we require that the inlet side be bolted to a solid steel mating flange. The seats of this valve are held in place with 2 little set screws, and they are not designed to withhold the back pressure of the valve. We rely on the mating flange to hold the internal components of this valve in place while in service. This is a standard 150-pound flange. The flange mates against the valve and overlaps the area where the seat fits in the body. So bolting this valve against a rubber-faced expansion joint, a groove-type flange adapter such as those made by Victaulic or Grinnell, is not to be done. We need a solid mating flange. Now let's look at the gasket and why you should use a full-face gasket. Again, there is no packing between here, and we're relying on this gasket to cover the interface between the guts and the body. With a full-face gasket, it's always centered properly. You can use a ring gasket, but we find that sometimes it's difficult to center the ring gasket within the bolt circle. If it's not centered properly, this thing could slide out of position, and you may have some leakage down the system, not on the floor, but leaking down the system, and it's because this ring gasket isn't centered properly. Use a full-face gasket, which will help center the holes, and let me mention also the bolts. If you use bolts smaller than what the flange bolt hole is calling for, this too may cause a problem. For example, a 6-inch flange has 7/8-inch diameter bolt holes and is designed for 3/4-inch bolts. If you use 5/8 diameter bolts, it will bolt up, but the valve may not be centered in the bolt circle. Use the right bolts, use a full-face gasket, and this silent check valve will work indefinitely. Hi, I'm Jim from Hammond Valve, and if you have any questions, please contact us or our local rep.